Good morning. Oh, there is people out there. Good, fine. I'm going to be going quite quickly because I've got a lot of ground to cover. And as previously mentioned, I'm between you and coffee, which is an important thing. And we've lost the left-hand side of the screen, so it's actually from ambition, not rum ambition. But we'll see if we can cope. It's good to see some old friends here. But for the new friends I hope to make at lunchtime and various things, this is me, been in computing far too long, but some of those numbers are actually worryingly large, but never mind. Been involved in the W3C community groups, mostly around schema.org and applying it properly, and working with various organisations like Google, OCLC. And specifically the National Library Board of Singapore, which is what we're on about today. National Library Board of Singapore, traditional national library, preserving Singapore's heritage, looking after the print collection, etc. But they also run a network of 28 public libraries servicing the community of Singapore and are responsible for exposing the National Archives data, which means they've got a lot of stuff. A heck of a lot of stuff, actually. So they've got over 5 million in their print collection, over 500,000 in Singapore and Southeast Asian cultural stuff. And the National Archives I'm not going to go through it all, there's just lots of it. And like many similar organisations, they provide access to it. And usually they provide access in many ways. So we've got, does the arrow work on here? Let's have a look. Yes, so they've got traditional OPAC, they've got the National Archives, a history portal, a local information portal, pictures, arts, music, and an electronic journal. And I've had the privilege to work with them over many years and help them build their ambition. And the ambition, which I think is not just Singapore's, I think it's an ambition that's been in this sector for a long, long time. And that's to enable the discovery of entities from different sources in a combined interface. How many organisations like ours do you go to the front door and find there's not one front door, there's several of them? So they wanted to bring together the resources, both physical and digital, and bring together the diverse systems that they have mounting these resources in a linked data environment, and to provide a staff interface to manage it all. So the journey started back in March 2021 with a traditional invitation to tender, a linked data management system, the LDMS. The key attributes of this invitation to tender was it had to be a cloud-based system, it needed a management interface, it had to acknowledge that the source data would still be curated at source. So the library catalogue will be the single source of truth for the library data. The authority system would still manage the authority data, etc. Needed to be linked data format. It needed a public interface that I've put down here is Google friendly. It's web friendly really, which means in the commercial web, schema.org needs to be somewhere embedded in the interface. And it needed to use wherever possible shared standards. And in the library community, that's BIBFRAME for the bibliographic work. It's not necessarily the only standard in town, but it's one everybody recognises exists. And from the web and other areas, schema.org is important. So the tender was awarded to a small consortium, which consists of Metafax, German-based company, who bring their Metafactory low knowledge graph platform to the story with semantic knowledge modelling and search and discovery in a semantic way. An organisation called Cuman, Singapore-based Amazon Web Services partner, public sector partner in Singapore, so quite used to working with Singaporean government people. And myself, trading as data Liberate, bringing in my experience from library management systems, schema.org, linked data, etc., etc., etc. So the initial challenges we identified when putting this together, lots of data, lots and lots of data, but all of it in record-based formats, Mark XML, Dublin Core XML, bespoke CSV out of the authority system. And implicit within that data, lots and lots and lots of entities. So from your Mark record, you're going to get a work, an instance, possibly an item, a person, an organisation, a subject. It goes on and on and on. We're going to get regular updates. As I said, the source data is in the library system, the content management system, the National Archives system, and they're going to be updating on a regular basis, daily, in fact, to update into this system, which meant automatic injection. We weren't expecting to have some poor librarian sat there moving files around every day. This had to happen automatically. Bringing data in from various sources, our system would not be the single source of truth. Both a blessing and a curse for the project, but very important. It needed manual update capability. No matter how good your automatic system is, it's not going to be perfect. And it needed entity-based search and discovery with web-friendly schema.org output to be used for Google and the others to harvest from public interfaces so we could share our data. So we came up with a basic data model. Linked data is the core platform. BIBFRAME to capture the nuances of bibliographic data. I'll use nuances politely, but all our bibliographic stuff. And schema.org to deliver structured data for the outside world. We decided on a schema.org representation for the content management data, the National Archives data, and the authority data from their TTE system. And then schema.org enrichment of the BIBFRAME data, which basically means schema.org became the lingua franca vocabulary of the knowledge graph. All entities, regardless of what other vocabularies are being used, we guarantee inside the system have schema.org, which simplifies a lot of the management and programming capabilities if you can guarantee that the entity you're looking at will have a schema.org type and a schema name. I talk about lots of data. We're talking about 3.1 million source records here, which expand out into 70 million different entities. So to handle this in an automatic data import mechanism, we implemented several data ingestion pipelines. This one I'm talking about here is from the library system. Source data comes in Mark XML files. The first step is to use the open source Mark to BIBFRAME conversion software shared by the Library of Congress. Outputs BIBFRAME in individual RDF XML files, one per Mark record. The second step is the enrichment step, where we use another open source tool from the BIBFRAME to schema.org community group, which, as an aside, I'm chair of that group. It's a Sparkle-based script, and it outputs schema.org enriched individual BIBFRAME files for importing into the knowledge graph. Another pipeline is the one that brings in data from the authority system, their TTE system. Source data is in a bespoke CSV format, exported in collection-based files, one for people, one for organisation, one for places, etc. There are interrelated references between people and places and organisations, etc., which makes it a little bit challenging. So we had to use it as a whole. So there's a bespoke Python script that loads the whole lot into memory and then creates schema.org entity descriptions, which are output in RDF for loading into the knowledge graph. There's a bit of a theme here. The last two pipelines, which are the National Archives system and the content management system, Their source data is in Dublin Core XML records. So the first step is to get it into an RDF format. Bespoke XSLT scripts translate from Dublin Core records to Dublin Core terms, RDF based. The second step is what we term TTE lookup. In this Dublin Core data, there are clues that some of the string-based names for people and places and things have been chosen by the cataloguers from authority data. So what we do is we look up against the knowledge graph to identify if that term is in the knowledge graph, in which case we use the URI of that entity rather than the string. The final step is to create schema.org entity descriptions for those and output RDF files for loading into the knowledge graph. Technically, this is implemented in Amazon Web Services with a standard Amazon EC2 Linux instance taking care of time processes, batch processes, and pulling in source data from a well-known spot on the National Library Board's network. It then fires off serverless Python scripts in Amazon Web Services Lambda. Great advantage of that is when nothing's happening, you're not using resources. When something's happening, there's plenty of resources around to do the heavy lifting. Those pipelines outputs, those RDF files are then loaded into triple store based graphs. Knowledge graph, we use Ontotext's GraphDB. It's very powerful, very flexible, and in the production environment we can run many nodes to handle the load. So we're getting from, you can't quite see it, but whoa, what happened then? Let's come back. What happened then? Oh, I pressed that button pretty hard, didn't I? There we go. So that's where I wanted to be. So you can see we're getting from record-based to linked data in a fairly simple architecture. Then that knowledge graph is used to drive a public access interface implemented using the MetaFactory platform, low-code way of rapidly developing a user interface into the data. And the second one is used to implement the curator access. We use two separate instances, mainly for security, so that the system that's allowing data change is not acceptable, but accessible by the public. Can somebody get me some H2O? There's an empty glass on here, by the way. If somebody could, before my throat dries up totally. So, I've pressed the button again too many times, haven't I? Right, so that's the architecture. Pulling this together, we identified that we need entity reconciliation. Lots and lots and lots of source entities, 70.4 million, and I'm going to say, with lots of duplication. For example, remember, when MARC records come in, we process them one at a time. So if you look in the library system, raw data, Lee Kuan Yew, the first Prime Minister of Singapore, there's 160 individual entities describing him in the library system. Another example, Singapore Art Museum, we've got 21 entities from the community content management system, 1 from the National Archives, 66 from the library system, and quite relievingly, if you like, only 1 from the authority system, which was really good. But users only want 1. So how do we get there? Oh, that's better. Right, I'm going to have to motor. We're running short on time. Mind you, we started off late, so I'm sure there's a little bit of laxness going on. Anyway. So 70.4 million actually resolves down to 6 million usable entities. How do we get there? Well, by overcoming some hurdles. We're not the single source of truth. We've got regular updates. So you can't make a change and not expect it to be overwritten by data being imported. And we need to do it in real time. We don't want to change from the library system to appear 6 months later. It'd be kind of nice if it happened the next day. So we developed an adaptive model as we port it. So we got source entities, individual representations of data that have come from the source data. Then we have a layer of aggregation entities, tracking the relationships between those source entities for the same things. This is not in copying attributes around, it's just linking things together. And then at the top level, we've got primary entities, searchable by users, displayable to users, and a consolidation of the aggregated resources. Let's have a look inside. This is the MetaFactory platform, one of the facilities to display the relationship between things. So I'm looking at a primary entity here, which is aggregated from 4 aggregation entities, one for each data source: the library system, content management system, national archives and authorities. So if we have a look what source entities the national archives and the authority systems have got, there's one of each. But if we look at the content management system, you'll see there's 21 source entities in that environment being aggregated together. And if we look at the library system, there's another 66. So we've got 80 odd source entities, if my math's correct, being aggregated down to a single primary entity when we've identified that they match together. Entity matches. The technology is based on some candidates based on schema names. One of the benefits of being a lingua franca, using loose index matching, giving us some candidates. Levenstein's similarity applied to make it a little bit more accurate. Obviously, we match against the same entity type, and some entity type specific rules, like if it's a work, we need to match on the name plus a creator or a contributor or an author or a same as relationship. For a person, it's a name plus a birth date, death date, or same as relationship. So we've developed what I would like to call the entity iceberg. At the top level, we got the primary entities which drive the public user interface so they can search and display. We've then got the aggregation layer tracking the relationships between the source entities to enable it to consolidate up into a primary entity. Remembering that the ingestion pipelines are running on a daily basis, so changing that source layer as we go along. And then we have the management interface, which allows us to see what's being exposed and manage what's going on under the waterline, if you like. Data management interface was rapidly developed using the MetaFactory platform, developed a collaboration environment for the curators so many curators could work on one entity. This was implemented using a pre-publish architecture. So you make changes, but you then decide when that gets exposed to the outside world. Search and discovery emulates the discovery interface. Got a dashboard view and management and creation of entities. So here we are in that data management interface, looking for Thomas Raffles. We find the record that we want, click on the information button, and we're looking at the information panel. I'm going to pick out 3 elements of data here to play with: the birth date, the birthplace, and the death date. Notice the birth date and death date have got 2 values, a single year and a year, month, day. Let's go and play with that in the editing form. So this is the entity management screen. And we can see here, we've got the birth date of a single year that has come in from the library system, the content management system, and the authority have got a more accurate year, month, day interface. If I click on the green button over here, it gives me the option to suppress that interface, not that attribute, not delete it, just suppress it. Do the same for the death date. And if I scroll down the screen a little bit, and we're now looking at the birthplace, you can see I've suppressed the birthplace of Jamaica because we have more information. Thomas Raffles was actually born on a ship off Jamaica. So we scroll down to the bottom, save the item, and you can see at the top here it's now flagged as modified. So we made some changes but not published them to the outside world. Let's have a look at the preview. We can see the birth date and death date have got the suppressed items in red. And if we scroll down a bit further, the Jamaica is suppressed and we've added the new entry, which is in green. If I then publish that, we have the ability to add in a comment. So we're adding an audit trail for the curators of what's going on. And now you can see it's in a published state up at the top of the screen. And surprise, surprise, there's no modifications to look at because they've been saved. Let's have a look at that in the discovery interface, same entity. A little bit more user-friendly. If we look at the details, we got a fair amount of detail. We've got links to the outside world. We've got an image that's coming from the content management system. Let me close that off. And you notice there's some relationships at the bottom here. Works by, contributions to works about. Let's have a look at the works by. You can see there is 50 odd works by Thomas Raffles. The first one on the list is the history of Java, which has got one version or instance, which happens to be in the library system. So we've got a link to the view in the library. Let's pick one of the about relationships and we end up in the subject of Indonesia Java. And we pick the first item on there, and there's the work display from the book by John Pemberton. As you can see, standard follow your nose navigation we're used to in the linked data world, which emulates the way the web works. So the system was put together and went live in December last year. Live for the data curation team using the data management interface. Live with the ingestion pipelines, pulling in data on a daily basis. Live for the discovery interface, ready for deployment, and live from a supported project. So the vendor team supporting and resolving issues and applying updates. The discovery interface, live and ready for deployment. So it's been performance tested, load tested, and user tested. But in the National Library Board, the data team who we are interacting with to build this system specified it to demonstrate the characteristics of a linked data interface in their environment. But services have rolled out by the National Library and Public Library divisions of the National Library Board, who have now identified a candidate service for this integration. And it's currently undergoing fine-tuning to meet the service's user interface requirements. I talked about regular data input. Here's an internal graph showing you the daily ingestion activity from December last year through to early June. As you can see, practically every day data is being brought into this system, and on many of those days we've been bringing in 25,000 items, so a busy time. Some challenges we met on the way: inaccurate source data. We went through a patch where URIs for subjects and persons were being mixed together. So we not only got Mr. Lee Kuan Yew, we got Mr. Lee Kuan Yew biography. Identified it was a source data problem, so it was fed back to the curators in the library management system, fixed the problem, and the next update change the data. So this is where the linked data management system is aiding the data quality enhancements across the library. We also had an interesting challenge with Asian name matching, where names of people and places quite often consist of several 3 or 4 character letters. Lucene is rubbish at giving you candidates for names like that. This is where Levenstein similarity matching helped. Tuning this kind of thing is challenging. When you get good at Asian names, you have trouble with European-based names and vice versa. It's definitely an art form. So, a summary. An ambition that the National Library Board had, which I think a lot of the organisations you work for share, was based on previous trials and experiments and based on things that were being talked about in previous SWIBs, etc. The ambition to deliver a production, and that's the important term, production linked data management system for curation, management and public discovery. With experienced commercial partners, hence the vendor team, but where appropriate, benefiting from open source community data. We had some unique and challenging requirements, distributed sources of truth, disparate data formats, auto-updating, needed to provide a consolidated view dynamically as updates come in, plus individual amendments, and being web-friendly. Live and operational, actually delivering benefits since December, and my voice is just about to give out. So, I'll shut up. Thank you for listening. Have we got a chance for a question? One question. If there's any more questions, myself and my colleague from Metafax, Dimitri, who sat over there, give you away, we've got one of the demo points at lunchtime, so you can come and find us wherever that happens. But who's got a question?
Try to do it quick. Hi, Richard. Thank you very much for the presentation. That's awesome work. I have one question. Sorry, that's going to be on one little detail. But you said that the library, they are in general, they are eager to keep to their source data and not changing it as a result of your project. But there seems to be a good case with the entity stuff, with all the duplicates. So when they see your system to aggregate them, aren't they interested a bit to sort of fold that back into their original data?
Yes.
Okay, thanks. Is it going to happen then? Am I allowed the second?
Well, yeah, I mean, we're in a position, it was a 2-year project to deliver this, and if you like, I think everybody is taking a little bit of we got there and it works and it's live, etc. Now what do we do? And there's issues about bringing in data from external sources, taking advantage of these knowledge graphs, embedding it in other interfaces, all under discussion. And to a certain extent, I think as the curators of the systems that are contributing to this system see the value and the benefit in that, the benefit will then go back in the other direction. But you know, how do you develop an elephant? You know, one bite at a time, to paraphrase the famous joke. So yes, but not quite yet.
Thank you again, Richard.